Hey guys, here with you again. We're going to be reading another couple of medical abstracts from NeurIPS 2022. This will be about EHRs or electronic health records and one on continuous treatments. So the first is EHRSQL, a practical text-to-SQL benchmark for electronic health records. And the second is generalization bounds for estimating causal effects of continuous treatments. All right, so the first one is the EHRSQL, a practical text to SQL benchmark for electronic health records, coming from Gyubok Lee et al. Out of KAIST. And the brief says a new practical text to SQL dataset for electronic health records, EHRs. The abstract: we present a new text-to-SQL dataset for electronic health records, EHRs. The utterances were collected from 222 hospital staff, including physicians, nurses, insurance review, and health records teams, and more. To construct the QA dataset on a structured EHR data, we conducted a poll at a university hospital and templatized the responses to create seed questions. Then we manually linked them to two open source EHR databases, Mimic3 and EICU, and included them with various time expressions and held out and unanswerable questions in the dataset, which were all collected from the poll. Our dataset poses a unique set of challenges. The model needs to, 1, generate SQL queries that reflect a wide range of needs in the hospital, including simple retrieval and complex operations such as calculating survival rate. 2, understand various time expressions to answer time-sensitive questions in healthcare. And 3, distinguish whether a given question is unanswerable or unanswerable based on the prediction confidence. We believe our dataset EHRSQL could serve as a practical benchmark to develop and assess QA models on structured EHR data and take one step further towards bridging the gap between text-to-SQL research and its real-life deployment in healthcare. And the EHRSQL is available at GitHub, and I'll have the link in the description, as well as a link to this poster and their NeurIPS page. All right. The next is generalization bounds for estimating causal effects of continuous treatments by Wang et al. And they say briefly that we theoretically provide and prove a generalization bound for estimating ADRF to guide the learning of adaptive weights that alleviate selection bias in the continuous treatment setting. The abstract reads, we focus on estimating causal effects of continuous treatments, for example, dosage in medicine, also known as dose-response function. Existing methods in causal inference for continuous treatments using neural networks are effective and to some extent reduce selection bias, which is introduced by non-randomized treatments among individuals and might lead to covariate imbalance and thus unreliable inference. To theoretically support the alleviation of selection bias in the setting of continuous treatments, we exploit the re-weighting schema and the integral probability metric IPM distance to derive an upper bound on the counterfactual loss of estimating the average dose-response function, ADRF. And herein the IPM distance builds a bridge from a source factual domain to an infinite number of target counterfactual domains. We provide a discretized approximation of the IPM distance with a theoretical guarantee and a practical implementation. Based on the theoretical analyses, we also propose a novel algorithm called average dose response estimation. Via reweighting schema. So it is an abbreviation for ADMIT. ADMIT simultaneously learns a reweighting network, which aims to alleviate the selection bias and an inference network which makes factual and counterfactual estimations. In addition, the effectiveness of admit is empirically demonstrated in both synthetic and semi-synthetic experiments by outperforming the existing benchmarks. All right, so that's it for those two. And I think this is the last of the medical set that I could find in NeurIPS 2022. There's also ICML, biomedical abstracts that I've read for you in another playlist. And I will be doing some other videos on other topics from those conferences. All right, guys, you have a good day. Take care. Bye-bye.